This year I've spent a lot of time, as you can see, on these NUBIC reviews. So each of these is an individual publication on an insect phylogeny, and these are cases where people have posted a machine-readable version alongside the visualization. This allows you to, in principle, analyze, do further analysis based on their phylogenetic result. But this is always somewhat complicated depending on how people format these. So you can see I spent a bit of time individually processing a phylogeny from each publication. The purpose of this is to synthesize these results. These are all individual contributions to the insect tree of life, and someone needs to actually put all these together. And I won't claim to be the first person to try and do that, but this is something I'm trying to do nonetheless. And one of the major results from trying this year was, you can see in this paper here, each of these we see these names. These are taxonomic names. These are from a subtree from that collection of source trees. These are all published source trees, and they are grafted onto this backbone. So this requires this database. You build up a database of these published phylogenies, and you can see this here. So for what I've published this year is for Diptera. This is a synthesis phylogeny of Diptera using the grafting approach. Where I've done a video, this is for a subset where people have, as I say, made the machine readable version available, and you can see this column here. Now in some cases NA, so is a publication which probably doesn't have machine readable version, but in many of them they do. I estimate this was about 25%. So in some cases, these are pulled from Open Tree of Life. Mendeley is a repository for data, and people often put phylogenies on there. Dryad, another widely used data repository. You can search Dryad and you'll often find some insect phylogenies. This, I'm not sure, this maybe is some other kind of repository. Sometimes you can try contacting the author and they will kindly send you a tree. And we have Figshare, which is a repository traditionally maybe for supplementary figures, I think, but there's data on here also. Some small number from retrieved from the author. Some of them you need to process them from the data repository, but actually the majority of those I have manually transcribed the figure. Now if this sounds very laborious, then that is very much the case. So here's a direct application of this data in the grafting, but certainly there's other applications. More generally, each published phylogeny needs to be combined in some way with all the other work which has been done, and here's one way which is curiously underused, this direct taxonomic grafting. I say curiously, it's because it's very intuitive and it's very efficient. You're not really doing any complicated analysis, it's just taxonomic matching, and it's intuitive in that we often have these transcriptome backbone which are very sparsely sampled at the taxonomic level, and then we have these much more widely sampled subtrees, so it's kind of intuitive to combine these in this way. And I've still only come across one other person who's done this, and that was for bacteria. And if I've missed something, then drop a comment. But this is an efficient option for synthesis. Now, there's a number of other ways one might go about building the insect tree of life, and even using all this collection of source trees can be integrated in different ways, and needs to be explored further. But the second major piece of work I wanted to review again is the application, because when we build a phylogeny and we go through the effort to build a very species comprehensive phylogeny, we need to apply this, and we've come up with an interesting application of using a phylogeny as a central framework for other forms of data and analysis. So you can see the phylogeny in the middle here, and we have also a lot of trait data is a second component, and a third component is a lot of queries, which are a community DNA samples, and we're able to use this reference species comprehensive reference phylogeny as this unifying framework for biology in this case, and these are functional traits which we are assigning to these. This data is available. Go to ScienceDB, Science Data Bank, and we have this specimen level data, which will be useful for further development of the methods for trait assignment to DNA barcodes. Now, DNA barcoding has been around for about 20 years now, but oddly, people tend to use it mostly for taxonomic assignment, sometimes for calculating phylogenetic diversity, but very few people have used it for predicting traits. Now, sometimes you'll see people calculating trait diversity on specimens which have also been barcoded, but you'll be looking to find any cases where there's been phylogeny-based prediction of traits for query data, which is what we did here. So this is quite an exciting application, additional application for DNA barcodes, and the valuable trait data. So this is specimen level data. So these are B specimens with barcodes and traits. So this will be valuable for further development of these methods. Otherwise, thinking ahead to 2024, we've got the International Congress of Entomology, which is looking to be one of the biggest events in insect science this year, or next year. So I think a lot of people are preparing work for these. I've submitted my abstract, so waiting to hear back on this, and maybe I'll see you here.